Right, in the last video we were looking at the double integral from 0 to 4 and from 0 to 8 of the function x plus y dx dy. Okay, and we had we're trying to approximate that as a Riemann sum, and we decided that when we made delta x equal to b minus a divided by, and we split that up into four pieces, that delta x came out to be equal to 1, and delta y came out to be 8 minus 0, also split into four pieces, came out to be equal to 2. So we were trying to show that we could turn the actual meaning of this double integral is to do the function evaluated at the left endpoint, 0 plus I times delta x, 0 plus j times delta y. And then we needed to multiply by delta x, delta y, because that was the area of the base, and the function values gives you the height. And together those make a volume. And then I needed to go from 1 up to 4, and j needed to go from 1 up to 4. Okay? And so what we showed here is that since we're starting our lower limit at 0, and delta x came out to be equal to 1, that this was equivalent, this double sum I going from 1 up to 4, the function evaluated at I, and delta y came out to be 2, so we needed to evaluate the function at 2j. J also needed to go from 1 to 4, and then we needed to multiply that by delta x, delta y. Okay, and the nice thing about that notation is that it can easily be put into a computer without having to like write out every individual term. You can actually write it as sigma notation, and that answer comes out to be 240. Okay, so for example, if we wanted to do that same problem, the integral from 0 to 8, but we wanted to split the region into, maybe 8 pieces in the x direction and maybe 16 of them in the y direction, we could easily have gone summation, summation. I would have gone from 1 to 16. J would have gone from 1, oh, sorry, M. I would have gone from 1 to 8, and j would have gone from 1 to 16. And then we would have had the function evaluated at I times delta x, j times delta y, and then we would need to multiply by delta y, delta x. But when n is equal to 8, delta x is equal to b minus a, the endpoints of the interval divided by the number that you broke it up into, and delta y would have been b minus a divided by 16 of them. So we could have pretty easily then created a double sigma notation. Let's go to the writing assistant. In Mathematica, you could insert another sigma, two of them, sigma. And then what would we wanted to do would be, because we have defined the function, you could say function evaluated at I times 4 over 8, which is delta x, which is a half, or you can say I divided by 2. And then j would have been multiplied by delta y, which is j divided by 2, 8 over 16. Okay. And then we would have needed to multiply by 1/2 times 1/2. That would have been the area of the base. The function gives you the height. And then we would have wanted I to go from 1 to 8. We would have 8 rectangles in that direction, in the x direction, and j would have gone from 1 to 16. And now that you've got this all typed in, you can evaluate that double sum to get 208. So we can see here is that as we take more rectangles, we're seeing the value getting smaller and smaller, and the question is there a limit? Okay, and that's what we're going to address in the rest of this video. So I'll add a page below, and we're just going to realize that the double integral of x plus y dy dx, y going from 0 to 8, x going from 0 to 4, that this is the same thing as the number of rectangles going to infinity in both directions. Okay. We would need to do a double sum. Okay. So let's let I go from 1 up to n rectangles, and let's let j go from 1 up to m rectangles. And then we need the function evaluated at I times delta x, j times delta y, delta x, delta y. And now we're saying that delta x, because we're taking the x and breaking it up into n pieces, we're taking the interval y split up into m pieces, right? So delta x is 4 over n, and y is equal to 8 over m. Okay? Then we can say that we need to first, step 1, compute this double sum. J goes from 1 to m, and I goes from 1 to n. The function evaluated at 4i divided by n, and the function for 8j over m.